We've been discussing the record warming during 2023, the causes, the impacts, and so on. And WMO puts out this report every year now for the last 4 years, I think. What am I doing here? Uh, it's called WMO Air Quality and Climate Bulletin, which came out in September 2024 for the last year. I'll just show some figures. There's a lot of text on the details of how the data are gathered, synthesized, processed, what are the uncertainties, what are the sources of the data, and so on, and the impacts, bioaerosols, impacts on humans, of course, crops, etc. And I thought it's worth summarizing this just because we have been discussing the 2023 warmth so much, and it is something that's going to be discussed for a while, and there are going to be many papers trying to explain why it was so warm. As we said, we don't know yet, and we don't have a complete answer, and also about the impacts and so on. Many of the sources of air pollution and climate change are the same. I've jumped ahead already in terms of the text. For example, the combustion of fossil fuels, a major source of carbon dioxide, is responsible for organic and inorganic aerosol formation and also emits nitrogen oxide, NOx as we call it, into the atmosphere, which can lead to the formation of ozone and nitrate aerosols. Similarly, some agricultural activities such as, which are major sources of greenhouse gas and methane, agriculture, rice paddies, etc., livestock, they emit methane, and also they emit ammonia, which then forms ammonium inorganic aerosol. Okay, the positive PM 2.5, again jumping ahead, anomaly over India, PM 2.5 anomaly over India, and the negative anomalies over China and Europe were caused by gradually increased or decreased anthropogenic emissions in the respective regions. Both datasets show agreement in terms of the direction of the trends, but the trends appear more pronounced in the ChemSRA dataset, which is one of the datasets, probably caused by the stronger trends in the underlying anthropogenic emission inventories. These are tricky always because they are very local, and it depends on at what scale they are done and what the quality control, etc. are. Assuming they are all of the same quality and rigorously quality control, you still have problems just in terms of the products. We have to deal with them. So the ChemSRA data shows a decreasing PM 2.5 trend over the eastern United States, which is not present in the GEOS-IT dataset. So there you go, serious issues in terms of even the direction of change. Keeping all that in mind, we'll look at some output. I'm also kind of interested in pollution, since we talk about climate change so much and the impacts, extreme events, and of course massive floods like one in Valencia that killed over 200 years. But overall, the number of deaths from natural hazards have dropped. They tend to be less than 1% of the total deaths, whereas cardiovascular diseases tend to be more than 30% for pretty much any country you look at. So climate change as such is not a killer, but you have to be careful what you mean by that, because climate change and air pollution are not independent of each other. But how do you focus resources on one versus the other? Are we giving too much importance to climate change in 2100, whereas air pollution is killing right now, and so on? Okay, you decide on those things. There are some serious issues that I've discussed elsewhere in other contexts, but looking at PM 2.5 in micrograms per meter cube, you see some hotspot here, and of course India and China-India contrast here is obvious, even though the data here, as we saw, depends on which data you look at. So this is PM 2.5 anomaly in micrograms per meter cube in 2023, and this is from CAMS reanalysis and NASA GMAO GEOS-IT data, and you can see some differences here. For example, even in India, the colors, the scale is the same, the colors are quite different, and eastern US is different here compared to here, and so on. So you have to keep these in mind. It's inevitable when this kind of very hyperlocal data is looked at, that is synthesized into global maps. Time series of monthly and annual area average PM2.5 concentrations over North America and Europe. So just for comparison, if you look at the two data sets, annual and monthly, you can see that the amplitude is smaller because these can be the annual data can be, let's see, there is CAMSRA in solid and dashed for yearly mean versus monthly, and there is GeoCit versus GeoCit yearly mean, and you can see the differences can be quite serious here in terms of micrograms per meter cube for monthly data and annual mean data. So we have to be always careful, and there are trends which are also different. So keeping all that in mind, if you look at global crop growing areas and hotspots for PM2.5 in 2015, and you can see the numbers here in high and low, average attainable yield of current cropland, kind of the potential yield. Okay, so crop growing areas shown as the average attainable crop yield, that's from FAO. Combined natural and anthropogenic PM2.5 concentrations, Sahara and Sahel and Middle East and northwestern Himalayan foothills and so on dominate here, and that's for PM2.5 concentrations modeled using greenhouse gas and air pollution interactions and synergies. That's the GAINS model. Concentrations of PM2.5 from anthropogenic sources only modeled using GAINS again. Here China and India light up, and India is surprisingly high. Here you can look at the micrograms per meter cube, and Himalayan foothills are way above what WHO says is safe level, which could be as low as 5 micrograms per meter cube or 10, some say 20, but we are way above all of those numbers anyway here. And here we are looking at geophysical PM2.5 concentrations determined using a combination of aerosol optical depths and ground-based measurements, where black dots represent monitoring locations. Basically the point is that depending on the source of the data, this can be very different, and then when you do the impacts, you are making many assumptions, and some process understanding exists, and there are debates about whether increased aerosol observations will increase or reduce the uncertainties or not, and so on and so forth. The multiple routes by which PM affects crops, particulate matter in case you don't know, including direct deposition to crop leaves and soil, so black arrows direct deposits here into soil and on leaves. Indirect impacts via effects on solar sunlight, for example, solar shortwave and diffuse radiation, orange arrows here. So there is direct, indirect impacts as sorry, this is just indirect impact. So you are blocking sunlight, affecting power, you will be affecting clouds, and so there is some absorbed, some reflected, some scattered, and you have cooling of air temperature, and because of the absorbed and scattered, you have reduced short wave coming into the leaves, increased diffuse radiation because of the scatter, altered cloud formation, changed rainfall patterns, unreliable monsoon transported to leaves after root uptake, which is from the soil deposition. So you can see there are multiple channels. All of them are kind of hard to track down, hard to empirically represent, let alone first principle models and so on and so forth. But we know that models are trying hard to include direct and indirect impacts. Often when we say indirect, it's also impacts on cloud properties, on droplet sizes, amount of rain, and so on and so forth. So you can go and read more details here if you want in another WMO report, but just remember that aerosols have climate impacts which are direct and indirect. They have direct impact on the leaves and available photosynthetic radiation, photosynthetically active radiation, and crop yields. And then there are indirect pathways where they favor formations of ozone and NOx, which again can affect crops, right? So multiple channels. Monthly mean anomaly in total aerosol optical depth at 550 nanometers for June 2023 relative to the 2003-2022 June baseline. And you can see that the northern US has had massive spike in June, obviously related to wildfires, and obviously the climate or weather patterns tend to amplify or trap sometimes inversions and so on, as it happens in many places like Delhi during certain seasons like winter, for example. This is the distribution of automatic bioaerosol monitors in 2018 and 2023. Dark green colors denote participants of the EU METNET Autopollen program, So 2018 and 2019, the number of sites have gone up. Bioaerosols, of course, biogenic aerosols, as we say often, are related to what the vegetation are emitting that get aerosolized as well, right? So components of the new bioaerosol observation paradigm, the report argues that biogenic aerosols are important and need to be monitored, modeled, looked for impacts and so on, and I'm obviously skipping all of the text and just showing figures. So bioaerosols, cutting edge technology, so you have spores, bacteria, pollen, people get seriously sick from these as well, so you have the various sites that need to be monitored. You have LiDARs, automatic in situ monitors, eDNA, which is basically DNA is shed by the vegetation when they release these spores, pollen and so on, and they can be used to track sources, sinks, and genetic sequencing, third generation sequencing and so on. And the internet and communication infrastructure with machine learning and big data can be used to map, especially fill the gaps in time and space in the data, which is very common in terms of the existence of gaps, and produce end user informations in real time or near real time data and forecasts, and lead to end users, which could be vegetation, crops, agriculture, health, and this is, schools. You can read. I'm being lazy again. So here is another example forecast of grass pollen concentrations for 27 June 2024 for Europe, and different models use Xylem model, pollen in millimeter cube, and for Switzerland generated by Cosmo Earth model, and categories from none to very strong. So here you have pollen in concentration per meter cube, whereas this is going just kind of a qualitative warning as very strong, moderate, and none. So the blooming periods are given for different sources like hazel, alder, birch, grasses, and ambrosia. But now the climate change superposition is that spring arrives early, winter comes late, winter is not as warm, so insect infestation, migrating beetles doing their thing, wildfires acting on top, and so on and so forth. So pollen is just one thing, but pollen season for people with hay fever has gotten longer and stronger maybe, and this is a serious health issue as well. This is just showing overall mean of the nano aerosol particles, so total and nucleation mode particles number concentration at 3 environmental conditions, so urban brown, rural green, and remote blue, and these are the annual trends in nanoparticle frequency, nucleation mode, particle concentration. I'm not going to get into too much details there, but basically there is PM 2.5, which is already bad enough because it gets into your lungs, your stomach lining, into your blood, and maybe brain. Street dogs found with PM 2.5 in their brain and so on. And then you have nanoparticles, which obviously are even more dangerous in terms of us happily breathing them, not even knowing what they are going to do to us, right? So this is particle number concentration, new particle formation trend, which are negative. Is that good news? I hope so. Nucleation mode particle trend, and potential cloud condensation nuclei trend. So you can go and read why there are negative trends and what the period of trends are. It could be just the difference from the previous year, but nonetheless just keep it in mind and look it up if you are interested in more details. Again, focusing on certain regions, time series of the maximum daily 8-hour averaged ozone, carbon monoxide in ppmv, nitrogen oxides and fine particulate matter from selected air quality monitoring stations for the period of January to March 2023. The lower panel shows the daily 24-hour active fires obtained from MODIS satellite at 1 kilometer resolution with colored bars indicating confidence, so high confidence and nominal confidence or low confidence based on infrared radiation emissions. Whether it's a fire or not has to be verified, so confidence in interpreting it is shown here. The map in the right shows the active fires during February in central Chile, Santiago metropolitan region, where most of the monitoring stations are located in the shaded region here. Okay, so where the fires are and where the monitoring stations are, but you can see that there was spikes in February, and then the background levels in aerosols, ozone, carbon monoxide, NOx, PM2.5 and active fires. Okay, so just giving you a sense. What's the conclusion? This fourth edition of the WMO Air Quality and Climate Bulletin surveys the state of the science and highlights some notable events that took place in 2023. And evaluation of PM2.5 anomalies for the year includes results from 2 global modeling centers, so CAMS and NASA's GMAO, and a discussion of their similarities and differences. A closer examination of ways in which PM adversely impacts agriculture is presented in the following section, which I'm not going to look at. Summarizing findings from, actually I will add it after this, I'll pause and then come back and add it. Okay, summarizing findings from the recent WMO report, the unprecedented North American wildfires of 2023, which are related to the warming, vapor pressure deficit, drying of vegetation, etc., and the air quality impacts on downwind areas in the region and abroad are described in the subsequent section. The advent of new monitoring and forecasting capabilities for biological aerosols or biogenic aerosols, which include pollen, fungal spores and bacteria, is then presented along with a discussion of the important connections between these bioaerosols and climate. The next section examines long-term records of aerosol measurements collected at WMO GAW global aerosol stations worldwide, and concludes that new particle formation events are decreasing in frequency. That's what we looked at the trend, with implications for cloud formation and radiative effects for both clouds and aerosols. So to the extent that aerosols are acting as cloud condensation nuclei and altering the properties of cloud droplets and amount of rain, clean air can actually increase the warming by reducing solar dimming, but also affect rainfall with direct and indirect mechanisms, right? So finally, the last section details an extreme ozone pollution event in Chile resulting from wildfires in early 2023, which is what we looked at here. Concurrent observations of ozone, carbon monoxide, nitrogen oxides and PM2.5 in central Chile exhibit the extreme detriment to air quality caused by intense and persistent wildfire events made more common in a warming climate. So I'm probably confusing myself about what I already talked about and what I didn't. So I've misplaced the text. So we already looked at the agricultural impacts, so crop yield, crop growing areas and hotspots of PM2.5. So you can see here average attainable yield going from low to high and mapping the PM2.5 here, and these are obviously different products. So this is geophysical PM2.5 concentrations determined using a combination of aerosol, optical depth and ground-based measurements where block dots represent the monitoring stations, and C is concentrations of PM2.5 from anthropogenic sources only, modeled using GAINS. Okay, so if there is some additional information that I missed, I will add it. Otherwise, see you in the next topic. This happens to me because I'm reading things, waiting for a while before recording them, because I do this when I get time, and sometimes I miss a few things, or I'm not being as careful as I should be. Okay, sorry.